And maybe there are some problems. The first one is about what ingredients. What ingredients we need for the production of the Portland cement? Do you remember? Remember? What kind of materials we need for the production of the Portland cement? The limestone and clay and gypsum. Another one is iron powder. Yes, iron powder. Okay. So, why we need to choose this kind of materials? Because the limestone can provide what? Can provide the calcium oxide for the cement. And the clay can provide the silicate and aluminate for the cement. And the iron powder for the burning or blasting of the cement. And the gypsum is for the preventing of the C3A in the Portland cement. Now this is the first question. The second question is, what is the proposal of adding gypsum to cement? Who can tell me? What is the reason? Why we need to put the gypsum into the cement? For what? Can you for what? Gypsum. Why we need gypsum in cement? Because when we learn the hydration of the cement, is also the hydration of the mineral compound. Yeah. This one is very special. This one is very special. What is special? Firstly, the reaction speed of it is the fastest. Yeah, is the fastest. And then the hydration product of C3A is no good for the strength of cement. And is harmful for what? It's no good for the strength and harmful for chlorine. Yeah? Harmful for the chlorine. So we need to prevent the reaction of the C3A and water. And then we need to put the gypsum into the cement. When we put the gypsum into the cement, okay, we put the gypsum into the cement, the C3A will react with the gypsum and water to get aggregate. This is good for the strength, especially for the early age strength. And that reaction is also very speed, is also very fast. So this is the reason why we need add the gypsum into the cement. And the amount of the gypsum must be optimal. If it is less, if the gypsum is less, the AFT, the aggregate, will react with the C3A. Get what? AFM. It is not good for strength also. And then the amount of the gypsum is also cannot be very, very big. Yeah. So this is the reason why we need to put the gypsum into the cement. The third question is what are the primary chemical reactions during the hydration of the Poland cement? What are the primary chemical reactions during the hydration of the cement? The hydration of the Poland cement is also the hydration of the minor compound. So these four, 1, 2, 3, 4. These four minor compounds will react with the water and get different kind of hydration products, such as CaSH, such as the calcium hydroxide, such as the CaH, CFH. Some of them is good, some of them is bad, or it's harmful. So these are the primary chemical reactions during the hydration of the Poland cement. And then the fourth one is what is the typical value for the fineness of the Poland cement? What is the typical value for the fineness of the Poland cement? The typical value is about 300 kilogram per. This is the fineness. This is the good fineness. This is the good fineness for the Poland cement. And the fifth question is define the initial setting and final setting. How to define it? Initial setting means the cement paste begins to lose the plasticity, begins to lose the plasticity. And the final setting means completely lose the plasticity. And discuss the method. Okay, the method of the method. And the sixth is please analyze the reason for volume soundness. What is the reason for the volume soundness? Three reasons. One is free calcium oxide. One is free magnesium oxide. Another one is gypsum. The reason why these three kinds of substances will react or will result in the bad volume soundness, because the reaction of them, firstly the reaction of them is very slow. It will react after the hardening of the cement paste, and then the reaction product is expensive. Is expansion. So this is the reason why expand. What the effects does the volume on soundness when you see a structure? You want to get a cellular damage, cracks, cellular damage, and poor quality of the concrete or the structure. So these are the 6 questions we just discussed. And after this class, you need to we can select some sample questions. Okay, this one, first one, and the second one. Okay, 3. Okay. First, this is 1, 2, 3. Okay, this is for our homework today. Okay, you can give them to me next week. Okay, next week. You can write them, you can type them also. Yeah. Okay? Yeah. Take a picture. Yes. Okay, we'll move on another section of about cement, Portland cement. What we can learn? No. We have learned the production of this Portland cement. We have learned the hydration of the Portland cement. We have learned the hardening and setting and hardening of the Portland cement. We have learned the technical properties of the Portland cement. We have learned the chlorine of the Portland cement. But the topic of what we have learned is about the topic is about the Portland cement. But the Portland cement is just one kind of cement. But for our civil engineering structures, the different, meaning the application is different. So we need to get different kind of cement. So we need to get the definition of the Portland cement. What is the Portland cement? It consists of maybe 3 kinds of materials. The first one is what? Clinker. Do you know what is clinker? Do you know what is clinker? No. What is clinker?
It's done.
What is clinker? Okay, this is clinker. After the burning of the raw materials, we can get clinker. This is before the burning or before the heating. And after heating, we can get the clinker. And clinker and gypsum. And some mixing materials for mixing a mixture. But the content of that mixture must be below how many? In Portland cement, below how many? How many percent? How many percent? Below 5%. Okay, below 5%. So for the Portland, there are two types of Portland cement. If just have these 2 materials, this is if 3 of these. But we have just learned the characteristics of the Portland cement have the advantages and also have the disadvantages. So if we want to use the cement for the construction at different fields, at different environment, at different conditions, we need to get different kind of cement or different kind of Portland cement. So we will increase the amount of the admixture bigger than 5%. And then we can get the mineral materials and mineral materials blended cement. So, firstly, we need to know what is the mineral admixture. What is the mineral admixture? And then, if we add some mineral admixture into the Portland cement, we can get the ordinary Portland cement. Ordinary Portland cement. So, what is the ordinary Portland cement? It means the content of the mineral admixture bigger than 5%, but lower than 15%. Yeah, more than 50%. And if we add a lot of glass fluorescent slag into the Poland cement, we can get this kind of Poland slag Poland cement. And if we add pozzolana into the Poland cement, we can also get this kind of. If we add a lot of flat ash into the Poland cement, we can also get that. And then, what is composite Poland cement? In this one, we just add one kind of mineral admixture. Yeah. And if we put two or more kind of mineral admixture in together, we can get this composite Poland cement. Because everyone also has the advantage. The slag has the advantage of itself, but also has the disadvantage of it. So we can mix them together and get the composite Poland cement. Composite cement. So firstly, we need to know what is the mineral admixture. The mineral admixture, why we need to add the mineral admixture into the Poland cement? Maybe there are three reasons. The first thing is to improve the properties of Poland cement, because we have just know there are some disadvantages for the Poland cement, such as the corrosion, such as the high heating. Yeah. So if we want to improve the properties of the Poland cement, we can add some mineral admixture into the Poland cement to get different kind of cement. And secondly, we can adjust the strength grades. Okay. What kind of strength for the Poland cement? What kind of strength for the Poland cement? 42.5 or 42.5 R. Yeah, 50.5 or 50.5 R. 6.5 or 6.5. So the smallest strength grade is 42.5, but actually it is no need for us to use this high strength cement. Such as if we want to construct a very simple road in the rural, in the small city or in the small town. If we want to construct a road, concrete road, it is because there are no trucks traveling at here. So the strength of the road may be not very high, and then we can add the mineral admixture into the Poland cement to decrease the strength grade, such as 32.5. Yeah, 32.5. So we can adjust the strength grade for cement. And then lower cost. How to lower cost? Why we add the mineral admixture? We can lower the cost of the cement. Okay. If the clinker is 100, if we just use it for the production of the Poland cement, maybe we can add maybe about 3% gypsum, and maybe below 5% admixture. And if we add maybe it's as 20%, 20% admixture, 20% admixture means it can be divided into 80 and 20. So if we add 20% admixture into the Poland cement, we can save how many? 20. We can save 20% clinker. Yeah, we can say
Sorry, motion.
say that again. Okay. During the production of the Portland cement, okay, here, if we produced 100 kilogram of clinker, if we produce 100 kilogram, just for example, okay, if we produce 100 kilogram of the clinker, and if we don't add more mineral admixture into the clinker, we just to make the Portland cement, So maybe this is for the this is for the amount of the Portland cement. But if we add 20%, okay, if we add 20% admixture into it, because the 20% admixture replaced what? It can replace the gypsum? It can replace the gypsum? No, it just replaces the clinker. It can just replace the clinker. So it can save 20 kilogram. It can save 20 kilogram clinker for cement production. Yeah? So it can. And the cost, okay, for these three kinds of materials, okay, the cost of the clinker is the most expensive. The cost of the clinker is the most expensive. So if we add much more mineral admixture into the clinker, we can save the cost. Okay. The mineral admixture can be divided also into two kinds of admixture. The first one is active, another one is inactive. What does active mean? Active means there are some reaction. And especially for the cement, what we can call it is active. Maybe it's good. It is good for the development of strength. Yeah, this is active. This is active, such as porcelain. So, does anybody remember about something about the porcelain? What is the porcelain? The porcelain is a kind of ash. After the blasting of the volcano. After the blasting of the volcano, there are a lot of ash. Yeah, this is the porcelain. This is porcelain. Maybe we can still remember there are three stages for the development of the inorganic binding materials. The first stage is the lime and the gypsum. And the third stage is Portland cement. In the middle, the second stage is the porcelain and lime. We can use the porcelain and lime together to get the binding materials. So this is a kind of active mineral admixture. For the inactive mineral admixture, it can just act as a filler. It can just act as a filler for the Portland cement, or to lower the cost of the cement. So this is for the mineral. What are the functions of the mineral admixture, and what kind of the classification of the mineral admixture? So, how can we define the active mineral admixture? The active mineral admixture means low hydration or hardening after grinded and pre-water. What does this mean? Huh? What does this mean? It means this is a kind of admixture. If this admixture is grinded and mixed with what? Water. Is there any reaction? Is there any reaction? No. No reaction. No products produced. No products that we can get. But after mixing with the NAM, and water, the reaction happens. We can get product. We can get different products. And this we call a secondary hydration. Secondary hydration. So for hydraulic cementing materials, just like the Portland cement, just like the Portland cement. So this is an active mineral admixture. What kind of active mineral admixture, such as natural porcelains, such as the fly ash, such as the plastiferous slag, The fly ash is a very, very useful and a very, very important mineral admixture for the cement and concrete. Why? Why? The fly ash is a byproduct. Byproduct also means no use, useless. Byproduct. It's a byproduct of the coal-fired power plant. Coal-fired power plant. And just like this. This is a fly ash. This is a fly ash. Okay? Do you remember what I have asked you? The question, why this mineral admixture is useful and is very, very important for the modern construction, modern concrete. Okay, look at the shapes of the particle. Look at the shape of the particle. It's circular, yeah, just like a ball. So what you can imagine it about this shape? It is good for the concrete. It is good for what property of the concrete? Because we just said it is useful for the concrete, yeah, and it is very, very important for the concrete. Why? Look at the shape of it. It's a circle. Like a ball. Like a ball means what? The flowability. Yeah, flowability. The flowability or the plasticity. So, the flowability or the plasticity, if the concrete made with this fly ash, the workability. Do you know workability? What is the workability? Because if we want to use the cement or want to use the concrete, we need to mix them and transport them and pumping them and construction them. Yeah? So during this stage, the plasticity or the flowability of the concrete or the cement is very, very important for construction. If the flowability or the plasticity is good, we can mix them it very easy. Yeah, we can pumping it very easy. We can construct it very easy. So, in modern commercial concrete, do you know what is a commercial concrete? The concrete for our modern construction, it's just like a good, like a goods, like a kind of goods, just like clothes, just like the vegetables. We can buy it from the plant. We can buy it from the plant, from the concrete plant. So this one is very good for the workability of the concrete. And then another reason, because it is a what we can call it just now. It's a kind of active mineral admixture. What is an active mineral admixture? It means you can react with the water and land to get the cementitious material, cementitious products. So it is good for the strength, especially the late age strength of concrete or cement. Third, with the heat, the hydration heat of it is very small. It's very small. So, especially for the massive concrete structure, this product is very important, and we need to add them into the cement or concrete. Okay? So, you must remember this one. Okay, maybe there are several other minor admixtures, but this one is the most important. This one is most important. This is maybe 20 years ago, 30 years ago, the fly ash is a kind of a byproduct. We using this, and really harmful. But now we can add them into the concrete. And also we can use this fly ash to produce different kind of building materials or building products. This is the production of the fly ash. And this maybe we can use it to. We can use it for what? Huh? This is what? This is a kind of aggregate. This is a kind of aggregate. Because the aggregate, the amount we used, the amount of aggregate we used is very, very big. Right? It will destroy the environment, destroy the resource. And then we can use this kind of fly ash byproduct to produce the aggregate. And then to produce the bricks. Different kinds of bricks. So it is very useful. So why it is useful? Because we just have said the fly ash or other kind of active mineral admixture. It's good for strength. Why it is good for strength? Okay, look at this reaction. Firstly, this is the chemical composition of the. This is the chemical composition of fly ash or some other active mineral admixture. It will react with calcium hydroxide. And also the aluminum react with the calcium hydroxide. Okay? And what is this? This is the this is the CSH. This is the CSH. Okay. When do this reaction happen? When does this reaction happen? Where does the calcium hydroxide come from? It comes from where? It comes from where? It comes from the hydration then. Yeah? Yes? It comes from then. So what does this mean? The reaction, these reactions these reactions happen at the early age of the same test or at the late age of the same test. It means after hydration, after the hydration of C3S and C2S, the calcium hydroxide produced. And then the calcium hydroxide react with the active mineral admixture and get much more space. So this is the secondary, okay? This is the secondary hydration reaction. The first reaction, the first hydration reaction of the okay. What is the first hydration? What is the first hydration reaction? The first hydration reaction is then, is above them, and is above them. So this is the secondary hydration reaction. So these are the active elements, and this is consuming calcium hydroxide. Okay. If the calcium hydroxide are consumed, it is good for what? Huh? It is good for what? It is good for strength, yes. It is good for, but also good for what? What we have learned just now about the corrosion. Yeah, the corrosion of the same test. So if the calcium hydroxide is consumed, the corrosion will not happen. Yes, the corrosion will not happen. Okay. So this is a hydraulic cementing forms. So this is vital point the active admixture. Well, for the inactive mineral admixture, it just acts as a filler. It just acts as a filler. And no harm to the properties of lime cement. As a coarse as the clay is locally set. So in active admixture, if there is a blast furnace slag, this kind of slag is cooled very fast. It's cooled in a very short time. But if it's cooled in a long time, this is a slow cooling slag. It is inactive. It is inactive. If the slag cooling short, very short, the time is very short. With fast cooling slag, it is active. So we can produce different kinds of blend Poland cement. If we add below 15% mineral admixture, and then we can get the PO. What is the PO? PO means Poland cement, ordinary Poland cement, ordinary. Ordinary Portland cement. Ordinary Portland. So this is the PS. PS means slag Portland cement. Because we add 20 to 70% of slag into the Portland cement. This is PS. And PP is Portland. Portland. PF is fly ash. PC is composite. Composite Portland cement. We can add one or two or more kinds of mineral admixture into them. So the hydration reaction. The fresh water, when it adds into the clinker, it will the hydration will happen. The hydration reaction, and it will react with the lamp and water and the active mineral admixture. and common cement hydrates. So this is the first reaction. This is the secondary reaction. 我们有加上 secondary reaction. Are you clear about this one? Firstly, the clinker reaction, the hydration of the clinker happens. It will get calcium hydroxide. Yeah. And then the active materials, the active minerals will react with the calcium hydroxide and get the cementitious products. Okay. Maybe we can, after the class, we can just look at the PV, okay, about the characteristics of this different kind of blended Portland cement. Okay, class is over. Yeah, it's time.